All right, we are still solving equations, but we are doing what's called a literal equation. This is 1.4. We're going to still use inverse operations to solve what are called literal equations. So a literal equation is an equation where letters represent both variables and the known constants. So that means we're going to have lots of letters in this. We're not going to get down to something that says x equals 2. We are going to have letters that represent almost everything in our equation. Okay, so Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. What equation can she use? So first thing we have to decide is what all these letters stand for, right? So I will tell you the I stands for interest. This is what you pay when you borrow money from the bank. It's like rent on the money. Okay, the P, I'm going to go like this, stands for the principal. The principal is how much you start with. That's how much you borrowed or you start with. R stands for rate. It's normally a percentage. You've probably heard like credit cards have a 15% interest rate, or home loans, I don't know if you ever heard it, but it's like 2.25% interest rate. So that's the percentage that you pay. That's how they decide and calculate how much you pay. And then T does stand for time. She wants to know the time. So we're going to take our equation, I equals P times R times T. So remember, when we don't have a symbol, we don't have a plus, minus, or divide symbol, it's always multiplication. So that's why I wrote multiplication. So the inverse of multiplying is dividing. So I want to get T by itself. That means I need to get that R and that P away from that T. And so the inverse, since they're being multiplied by T, the inverse would then to be divide by them. P times R divided by P times R is still just 1. Okay, just pretend they're numbers. 25 divided by 25 is still 1. Now if I did it on that side, I have to do it, not I, PR. Just change that to a P. R. And we get that the interest divided by the principal times the rate will equal the time. And guess what? We're done. So this is what a literal equation is. You manipulate an equation till you get to what you want. Okay, the initial equation had us find the interest, but I wanted to find the time. So I had to change it using inverses to find time. Okay, so this one's got a couple numbers in it, which is fine. But notice we have 2 variables still. We want to solve for y. So just like when we're solving for x, or like in the last equation, t, we don't move it. That's the last thing we want to move. So we're going to actually move the 2x first. We're going to get rid of that, just like if it was the number 4. All right, a whole number. So I'm going to solve it and move it to both sides. We can do this just like when we're trying to move x's to get with the other x, correct? So it's the same idea. So we get 3y equals, I like to write it like this. I like to put my variables in front, always. Same thing, right? Negative 2x. And then to get y by itself, this is multiplication, so the inverse is to divide. So you can write this 2 ways. We can leave it like this. Okay, you can leave it like that. Or we can actually divide the 2. So this becomes a fraction, negative 2 over 3x, because it doesn't reduce. And then you can reduce the other side. 12 divided by 3 is 4. So both of these would work. And there we go, we're done. We can't clean up anything else. That's our literal equation. So if you look at the next one, it's almost identical, except now we have no numbers. But we're going to solve it exactly the same way. Okay, so maybe this would be a good time for you to pause and try it and see if you can do the steps the same way we did the last one, just with this one that has no numbers. So hopefully the first thing you did was subtracted our hx, because that's what we did here. We moved our x first because we want to leave the y alone. So we would get cy equals, we can do just set it up the exact same way we did in the last one. Put that x in front. And just like we divided by 3 here, instead, we're going to divide by c here. And we're going to get y equals negative hx plus m over c. Now, just like we left it here, we can leave it. If you really want to break it up, you can. We can do it like this. 2 separate fractions. These are both the same. So it's up to you. They both are equal. But we can't combine anything. They're all different variables. Nothing's the same. So that's it. Those are our 2. 1, 2. Okay, we're going to solve for y. This is distributing first. We're not going to try to solve or move anything until we distribute. So let's distribute first. Y times a, we can either do ya or we can do ay. Let's do ay. Since we're trying to solve for y, I'm going to make it kind of like our quote unquote variable, right? Minus by equals, sorry, got distracted. I apologize. Cy plus, we'll just go Ca. So we need to get our y's on the same side, so let's minus this cy. We get ay minus by minus cy. And that's going to leave us with ca. So we need to get y by itself. What I'm going to do is actually a kind of like an opposite distribution. I'm going to factor out something that's in common. So if you notice, there's something in common on our left side. Every single one of those has a y in it. So I'm going to distribute it out and get that y kind of back out. All right, so it's going to look like this. I'm going to pull the y out. Basically what I'm doing is I'm dividing all of these by y. So I'm left with a here, minus b here, and minus c here, and then ca. Okay, so I'm going to distribute that y out. And now this is y times all of this, and remember the inverse of times is divide. And so we get y equals our ca divided by a minus b minus c. And there we go, we're done. Because nothing can be combined, nothing can be reduced, and now y is by itself. All right, solve for y. Let's see if you can do this one. Maybe pause and see if you can try this one. If you'd like, you can even do maybe 1 or 2 steps and then pause, unpause, check it out, 1 or 2 steps, and then pause and check it out. Okay, so the way I would do it is I would distribute first. So I would get x equals 3y minus 3b over m. Right? Then inverse operation, I'm going to times by m. Like this, that gets rid of these. And so now I have mx equals 3y minus 3b. I'm going to add 3b to both sides. Just like that first problem we did, or the second problem, we added that x, same thing. So I'm going to get mx plus 3b equals 3y. And then we divide by 3. And we're going to get mx plus 3b over 3 equals y. Notice I kept the y always on the same side. We're not trying to flip this. Now, there is another version of this. Let's see if you can write the other version, and then we'll check it when we get back to class. So remember, we can kind of split this up. So see if you can write it. We'll check it when we get back from class. So I just realized the independent practice is the exact same question we just did. So I'm going to have you do a different one because that's silly. So we're going to cross that off. And I'm going to have you do this one. So W equals X over A minus B. And I want you to solve for X. Oh, jeez. All right, solve for X. There you go. Sorry. Didn't realize that was the same one. Okay. Come with questions. Get that independent practice done. Until next time.